Hello everyone, this is Suresh from Azure ADB. Today our topic is how to generate surrogate key as a column for data frame. So what is this surrogate key? So it is like how to add sequence number generated as surrogate key in your data frame. So we can achieve this by different methods. So here first method is monotonically increasing ID using MD5 and using CRC32 hash and SHA1 and 2 and using window function row number. So we'll see one by one how to generate this surrogate key. So first one is monotonically increasing ID. So this one generates a sequence of numbers, or you can say surrogate key. The monotonically increasing, this is the function in PySpark, monotonically underscore increasing underscore ID. So this function is useful for generating unique identifiers for rows in a data frame, and it generates a column with monotonically increasing 64-bit integers. Okay, so that means whenever you use this function, it will add to your data frame one new column. So that column has 64-bit integers. So each and every number has unique identifier. So, okay, so that means non-repeated. So what is this main key characteristics? So first one is monotonically increasing. So what it means? So the values generated, it is guaranteed to be monetically increasing and unique. So that means it don't have duplicate. Every number is unique and it is in increasing order. But we cannot guarantee it to be consecutive. So we'll see why this is happens. So second one is distributed processing. So since our Apache Spark, it is a distributed uh, contribution. What it happens is IDs are not unique across partitions. So because whenever you give data frame, it will first divide into number of partitions. So for each partition, no, so IDs numbers will change. So what is non-consecutive IDs? Since IDs are generated in a distributed manner, they are not consecutive. So we'll see in example what is this one, non-consecutive. So what is the syntax? Syntax is this one, monotonically underscore increasing underscore ID. So inside this, no need to pass any arguments. So you can keep blank. And what it returns is, it will generate a big integer number. So first what I'm doing, I'm importing required functions. So mainly monotonically increasing ID, Spark partition ID, contact underscore WS. So first we'll see with example consecutive numbers. How to generate consecutive numbers. So what I'm doing, I'm using Spark range function. So I'm taking range as 1000, okay, 0 to 1000. And on top of that, I'm using with column function. My column name should come as ID, and I'm giving this function, monotonically increasing ID function. And on top of that, I'm using one more with column, and I'm giving column name as partition underscore ID. I'm using this function, spark underscore partition underscore ID. So now we'll see why we are using this function. So since we are using range 1000, what it does is spark dot range. So this one by default, it generates single column ID. Okay. So if you see here, so I'm trying to show df equal to spark dot range 1000, and I am displaying. So what it does is it generates by automatically one ID column, and it ranges from 0 to 1000. Okay. So we'll see that. So on top of that, we are using with column ID. So that means existing column, it will overwritten. See here. So by default, see, we are not given here any column name. So by default, it taking column name as ID, and it generating values. Since we given 1000, no, so it generating from 0. Okay, 0 to 10,000. It generating this many rows. So the first one is that one. Second one is I'm using with column ID. So that means I am doing transformation on existing column only, this existing column. So what I'm doing, I'm giving this function monotonically increasing ID. So that means it will generate from 0 to in increasing order with unique identity. But why I given this partition underscore ID, this function is what it does is, so it display for each and every row, suppose this row belongs to which partition. Okay, like each row it will display belongs to which partition. So if you see 0, here 0 is there, partition 0, we'll see how many zeros in partition, first partition. So parallel you can calculate also. So for time being, I'm showing a manual way. See, first 125 records, it is coming under partition 0. So why I wanted to use this function is, I want to show you, see from 0 to 124, it coming as consecutive in increasing order. So that is this meaning. See, unique identifiers, it is increasing and unique. Okay. And what is this second one? Not guaranteed to be consecutive, because they mentioned distributed computing environment. So that means once you give either data frame, it converts into number of partitions. See, up to first partition, it generated consecutive numbers 0 to 124. See here, next it's starting with the second partition. See, second partition, see it started with some 10 number digit. But from here onwards, it will be incremental way. See, 592, 593, 594, 5 like this. Okay. So from here, unique number, incremental way. So it is not like that it ended here 125. Next, it will start with 125. So that is the meaning. It is not guaranteed to be consecutive. So similar way, if you observe partition 2, see from here, we'll see how many records it generates, and the next partition from which number it started. See up to here 716. Okay, so from here onwards, second partition is starting. See, if you see here again, this number is different and number of digits also different. But whenever started with this value, from here onwards, it will be incremental and unique number. See 184, 185, 186, 197, like this. Okay, so like this it will go. So that is this one, monotonically increasing ID. This is just to show, explain about this non-consecutive. So next, non-consecutive numbers. Okay, so this we covered here also. So I will show one more example. Here what I'm doing, spark dot range 10. Okay, so you can try with this range 10. So here I tried with range 20. So I'm applying same functions. See here, first uh, first partition we have only two rows. So it started with 0 and 1. See second partition, see it's a totally bigger number. See 1 to this number. Okay, so second partition, see again different number. So third partition. Okay, so this is non-consecutive numbers. Okay, non-consecutive numbers. So next, so I'm trying to read one data frame. Okay, so this is my data frame and I'm reading this. So I have this many columns. So on top of this data frame, I am applying this function, monotonically increasing ID. And my new column name is ID underscore key. Since I used the with column function, it will create one new column ID underscore key and it will generate monotonically increasing IDs. See, this is my, it's starting with a 0. Okay, up to 99. So I have total 100 records. It generated from 0 to 99. So might be it considered as single partition. Okay, so next what I'm doing, how to set custom starting point. So what it means is, see now we use this with column function, monotonically increasing ID. So that means by default, it will start with 0. Okay, so sometimes we don't want this surrogate key starting with 0. So we wanted to start with our own number. So sometimes 0 is not good for surrogate key. So that's why I wanted to start with 1. So what I'm doing on top of this column with ID, with this function, see by using this function, by default, it will start with 0. So for that, I'm adding this variable start underscore ID, that is 1. Okay, so that means it will start from 1. Instead of 0, it will start from 1. Okay, so similar way, I given 1. Maybe you can try with some other number also. So here I'm trying with 1000. Okay, for this variable. So now what it does is it will start from 1000. Okay, so depends on your requirement, you can change this one. So next we'll go for second method. So how to achieve this using CRC32. So what is CRC32 is cyclic redundancy check value. So it will convert binary column and returns the value as big integer. So we should not use CRC32 for generating surrogate key on large tables. So large table means suppose you have millions of records. So what is the disadvantage is if you apply this CRC32, whenever you have data, millions of records, what it does is it will generate duplicate surrogate keys. So it is not advisable to use for large tables. So what is the syntax for this? CRC32 and your expression. So expression is a binary expression and what you will get output is big integer. So what I'm doing here, I'm using with column function and I'm giving this column name as this one and I'm applying this function CRC32 on which column? This employee number column. Okay, employee number column I'm applying and I'm converting to string because it takes, this function takes only string type. It won't take integer type. So we cannot apply on integer column. So instead of taking employee number, you can directly select any string value also. Okay. So if you are selecting integer column, you just convert it to string type. So now what it does is, since we given new column crc32 underscore key, if you see at the end, see one column is added, and this is how it will generate surrogate key numbers. See, these totally different. So this is not unique and not in increasing order. So it giving some default numbers. So for each row, it has a different numbers. See, size and length, everything is different. So that is this one, CRC2 32. So now I applied on one column. Okay, so you can try on multiple columns also by using concat function. So this function, when you'll use normally, suppose you have some confidential information on any particular column or multiple columns, you can apply on this column and you can convert like this and you can share to your supplier or third party. Okay, so that is the main advantage of this function. Sorry. So next, I am trying by using concat. I told no. So now we saw how to apply on single column. Now we'll see how to apply for multiple columns. So what I'm doing here, I'm using same with column and I given column name as concat. So here I'm using concat function. See, from SQL function, I imported concat. So from I'm using concat on these four columns. If you see here, sales, quantity, commodity, commodity, experience. So I selected some integer columns. Okay, sales, quantity, commodity, and experience. So experience is somewhere here. Okay, so I selected all integer columns. So what it does is, first it doing concat. It will do first concat of all these four columns, then it will apply this function. So yeah, in this concat, no, so I'm trying to do only concat. Okay, so concat means since we are given any delimiters, so it will directly concat these four columns. So here what I'm trying to do, first I'm doing concat. On top of that, on top of this column, I'm using this function crc32. So this is a column name. See, for each row, it generated some number, surrogate key number. And the third column, so I want to display, is there any duplicates while generating this one? So for that, I'm using row number function. So row underscore number, and I'm using over window dot partition by this column and order by this column. So it displaying order. Okay. So how many times if it is repeating? See, 2, 3, 4 are there. So finally, what I'm doing, I'm filtering only greater than 1, greater than 1 records. So that means I'm trying to display how many duplicate records it generating, this particular CRC2 ID. So that initial itself we discussed, no? So disadvantage of this function, it will generate duplicates. Okay, so I'm assuming that you already aware this window function. Okay, so you can try separately, like so row number over this one, this function you can try it. Okay, so here we is a concat, no? So concat of multiple columns. So first one is sales quantity. So what is sales? Sales is this one, 98765. And if you see here, see first 98765. Next, what is there? Sales quantity commodity. Sales quantity commodity 2060. See after that 2060, and next one is 43680, and the last 6 is, that is experience column, this one. Okay, so since we are not using any delimiter, so it combining all together. Okay, so on top of this, it generating this surrogate key. So next we'll see for next function by using MD5. So this also generates duplicates whenever you have large number of records. So this also not suggestible to use while generating millions of records. So what is this function? From functions, I'm importing MD5 function. So here I'm using with column function. I'm trying to create new column, and this MD5 function I'm trying to use on this employee number column. So this also we cannot apply directly on integer column. So that's why I'm converting to string type. Okay, so if you see here, see it is generating like this. If you see earlier method, crc c5, see it generating only integer numbers. Okay, and in this method, see it combination of integer and characters. See, that is a difference. And next we'll go for hash function. See, this one calculates hash code of given columns and returns the result as integer column. So this also same thing, mainly we can use for to mask sensitive information like date of birth, security number, IP address. Okay, so these things we can mask it by using these functions. Okay, hash, previous two functions. So so we'll see how to apply this function. So I'm using with column function, trying to create a new column hash. So I'm applying hash function on top of this employee number. So what it generates at the end, we have hash column. See, this is how it generating. See, it generating even negative, positive, negative integer numbers. Okay, so each and every function, it has one different way of generating numbers. Okay, so next we'll go for SHA1 method. So from functions, I'm importing this SHA1 function, and I'm using with column function. I'm trying to create new column SHA1 underscore key, and this function I'm trying to apply on these three columns. So first what I'm doing, I'm concatenating these three columns. On top of that, I'm using this SHA1. So what it does is, if you see at the end, it generated one column. See, this is how it generating surrogate key. So this also has combination of integers and characters. This is about SHA1. Next, we'll see how to use this SHA2. So what it does is, if I'm trying to create with column, and I'm giving this column name as SHA2 underscore key, I'm using this SHA2 column, SHA2 function on top of this employee number column. And since that is integer, I'm trying to convert string. So here in SHA2, what is the advantage is you can give these bytes, how many bytes you want to generate, size of the surrogate key. So here I'm giving 256 bytes. And if you see this column, see it limiting to 256 bytes. And if you see SHA1, so we don't have control on this. So this is a default, it will generate a default bytes. But in SHA2, we can control with how many bytes we want. So since I given 256, it generating within that limit. And second one, see here I applied on single column now. So here I'm trying to apply on multiple columns. So here what I'm doing, this is my new column. So instead of concat, I'm using concat underscore ws function. So this is my delimiter, and so I'm using lit function. So one new column that is salted, that values will be salted, and I'm concatenating with the column employee number. So this one, I'm concatenating this one. So it will come as salted underscore employee number. Okay, like that it will come concat underscore ws. So next, on top of that, what I'm doing, I'm creating one new column, and I'm using this SHA-2 function on this column. So whatever concat it generated now on this column, I'm using this SHA-2 function. So since this also integer, I'm trying to convert to string type, and I'm limiting to 256 byte. So we'll see at the end these columns. If you see here, first we are using concat underscore ws now. Since we given lit, so all the rows it is started with salted underscore this employee number value. So this particular column, whatever value is there, it will come here. So on top of this column, since we are applying SHA-2, so it generating these keys. Since it is 256, it limiting to 256. See, I given 256. Now we'll see I'm giving some random number, some 200. See it throwing error. So it has some dedicated numbers. So we had to use only these numbers only. See, telling that requirement failed. Number bytes 200 is not in the permitted values. So now I tried for 256. So you can try your side by using these other values like 0, 224, 384, 512. Okay. So whenever using this function, just keep in mind it allows only these values. And final one, by using window function, row underscore number. So here what I'm doing with column function, I'm trying to generate new column, row underscore number dot over window. So I imported from here SQL dot window, import window, and partition by lit. Lit I'm giving blank, and dot order by blank. So what it does is it generate surrogate keys. If you see at the end row underscore number from one to in unique way and incremental way, it generating surrogate key. So you see like first type monotonically increasing ID, it generating by default from 0, but it is generating from 1. See these are all about different functions on how to use surrogate key. So it depends on your requirement and project requirement. You can choose wisely which method suits for your requirement. So each and every function has their own advantage and disadvantage. You can choose wisely. That's all about this video. If you really like this video, please like and subscribe. Thank you.